Costmine USA Sherpa for mineral processing plants is an application designed to help evaluators estimate the capital and operating costs associated with recovering valuable minerals from a specific feed. They market this as a scoping level or early stage pre-feasibility cost estimating tool. But you'll find that the extensive nature of the equipment lists, the workforce requirements, and the supply consumption rates will provide the kind of information you need moving forward into the later stages of pre-feasibility estimates and even on into the early stages of final feasibility. The tool uses cost information provided by Costmine USA out of their mining cost service database, and hopefully does a lot of the work you need to do to help design a plant and estimate the costs associated with that plant. I'm going to work through a quick example here just to show you a little bit about how it works and what it does and the kind of information it will provide. You can of course work in either English or metric units. So let's take a quick look here. You'll see that the program presents as a series of in-echelon menus. Users typically work more or less top to bottom, left to right through these menus to come up with their results. You don't need a lot of information to get a fairly reliable result. All you really need to do is input a size of your resource, an estimated production rate, an estimate of the size of your feed, and one of the more technical issues you might have is you do need to have an idea of how fine you'll need to grind it, if that's the kind of plant you have, to recover the minerals you're looking for. You need to enter the type of deposit you have. You can see here we have anything from epithermal through porphyry, volcanic hosted massive sulfide, skarn deposits. Let's go with the carbonate hosted stratabound deposit. And our primary commodity in that will be copper. We'll need to enter a grade, 6% we'll say. And let's say there's a little bit of silver, let's say there's a little bit of lead in there. And we want to recover that as well. And a little bit of silver. So you just need to enter the commodity types and the grades. And then you need to know the ore minerals so the program can have some idea of the nature of the feed into the mill. So let's say that the copper is associated with chalcopyrite. You can see that it will tell you roughly what contribution is common as far as how much of the rock, how much of the feed will be chalcopyrite, and the density of chalcopyrite. Let's say we have a little galena as well, which contains the silver and the lead, and we'll say that let's say we have a little bit of quartz in there as well. And we'll say that our primary rock, the rock that's going to be discarded, is a quartzite in this case. You can see the program has done a couple things. It's telling you you probably will want a two-product flotation mill. It estimates a bond work index based on the nature of your feed, the constituents. So let's move on from here. Now we suggested a two-product flotation mill, but you can see there's a wide variety of processing approaches you can take. So you can change the type of mill if you don't agree with the suggested mill that the program decides would be most appropriate. These recovery rates are based on information from operating mines all over the world. Now, Based on the flow sheet design and the information we provided, the program is going to go through and estimate the amount of material that's going into each machine, the amount of valuable minerals going through each machine, and the amount of fluids or solutions that go through each machine. Now, these flow sheets that are provided by the program are fixed, so you can't go in and change the configuration of the flow sheet itself. But again, it's a scoping level or early stage pre-feasibility tool, so we're just trying to come up with a good, reliable number, but not a final feasibility stage type result. One of the prime advantages we feel of this program is that you can go to any machine in the flow sheet, click on it, and the engineering parameters used to define that machine are listed here. And most of these you can change. So we've got a regrind ball mill that's processing 52 tons per hour there. The feed size, the product size for that particular mill, and it uses all this information to come up with a diameter for that ball mill, the length, and the horsepower requirement. And of course that information can be used to estimate the purchase price and the operating cost. With this flow sheet in mind, with the machines defined, we can go on to look at the flow balance. Will give us some information on how many tons a day are going into each machine, how many tons of concentrate are coming out, how many tons of tails are coming out. And this goes all the way through the end of the plant to where we come up with our products in this down here. We also can look at the solution flowing through each plant, in liters per minute in this case, along with the sizes of the materials, so as they go through each machine. So that helps define the nature of each machine. Now, in addition to just the processing plant and the building itself, the program does provide some other costs that will be helpful in determining the economic viability of your project. For the site development in this case, it tells you how many the nature of diversion channels, the mill building footprint, clearing and grubbing that will be required, the amount of site excavation that will be needed. You can change the type of building construction methods for both your plants and any ancillary buildings, and we're also going to provide a tailings impoundment for you. We suggest this information, but you can change most of it, as you can really anything that the program suggests. So we say a slope impoundment here. If it's a valley fill, you can change, and it'll take care of, adjust any calculations beyond this point that would make it more applicable for a valley fill. A little more definition of the tailings impoundment. It defines the construction material that it'll be made of, which is based on what we defined as the waste rock for the project, the gangue minerals. And it also very carefully goes through and defines the impounded material, how many tons per day it will be impounded, the total amount, how much needs to be contained, the final capacity, settled density of the material. So it's doing a lot of calculation work, which will hopefully save you time. If you need a camp or any other ancillary facilities, you can enter that information here. Let's say that from some other source we need 42 workers for our mine, 37 for our mill, and we'll say that we need a dormitory. We can select the construction method of that dormitory here. A cafeteria, same thing. A rec facility. And we can also steer this project to how it's accessed. If we have a camp, we're going to assume that Getting men and materials and other equipment out to the site has to come one of several approaches, and we'll say we use an overland approach. Because it's a processing plant, we'll be needing some water, and here we go through some of the parameters needed to define the water system we're going to have to handle both feed water and water that comes out of the plant that isn't associated with the tailings. Supply calculations are inherent in the program and are based, of course, on the flow sheet we've defined along with the nature of the feed. The prices for all these materials are out of mining cost service, as are things like the electric rate, diesel price, fuel oil price, natural gas price, and any of these we can change. It's really an advantage of the program that we like to feature, is that you're not stuck with anything we come up with. You can change everything that we suggest, except in this case, the actual flow sheet. Wages and salaries are also from mining cost service. And again, as always, if you have more representative information for your location, you can overwrite anything we come up with. So in this menu here, we have the machines that appeared in our flow sheet, and really this is just another way of looking at the screens that we mentioned earlier that help define the machine. So this is that ball mill that we looked at with the feed rate, feed size, product size, retention time. That came up with our diameter, length, and horsepower. So you can change these parameters if you want to further adjust the machine capabilities to what you feel your requirements will be. Here we get into a little more of the engineering aspects of the work the program does. Pad and pond construction are mostly for situations where you would have a heap leach. So we won't go there. Our tailings impoundment, though, is defined here. Gives you a width, a depth, a length, a maximum dam height, the contained volume, how much construction material will be needed. And here we have the initial construction costs for this impoundment, along with the annual construction costs, assuming that this is a facility that will be enhanced and extended as the project goes on. So we start with a fairly small impoundment and we keep making it larger and larger as the project progresses. Our camp construction costs are here. Based on our earlier entries, we have a workforce size, a capacity size for the plant or project, how many rooms, the footprint of the camp itself. We can also change essentially where the climate of the project location to help decide what is needed in our buildings and our structures. So if we went to an Arctic environment, we would change the initial construction costs of all our buildings. And for operating our camp, we have the cost per ton processed. Our equipment requirements are listed here. So we have every machine that was in the flow sheet, the size of that machine, the number needed, and the purchase price. And it goes through all of our flotation cells. In this case, we're using fairly small cells, but you see the overall cost of those cells. All the way down to the very last machine in our plant, which is essentially a conveyor to get rid of to transport some of the dried product. On the screen, the power generation requirements are defined. We did say we have a camp situation, so we're going to have generators here. It'll tell us how much power we need for both our project and our camp. And if we have any on-site transmission lines, they'll be entered here. Our workforce is defined here. We, per shift, tell you our idea of how many workers will be needed. And again, as with everything else in this program, if you don't think our numbers are right or representative of what you would do, you just overwrite what we come up with. Our staff, on-site staff, is also defined here. And last but not least, our supply requirements are listed here. In this case, grinding mill media, kilograms per ton feed, collectors, again kilograms per ton feed, frothers, flocculants, and some of the more specific reagents needed for our plant that we define, our copper, lead, silver feed flotation plant. Daily energy requirements are listed here. Fuel oil for drying our feed, drying our product. Electricity to operate the plant. So if you need to know the daily requirements, they're listed here. And that's pretty much it for input. From here we go to the results screen. I'm going to start down here with our equipment purchase. So I've got all the purchase prices and listed here along with the installation costs. And so we see that in this case we have about $8.5 million worth of equipment purchase prices, but over $14 million in charges to install all these machines. And we have a breakdown of those installation costs here. So let's look at that ball mill. I think it was this one right here. So the ball mill is relatively not a very big one, but the labor to install that would be $143,000. The concrete we need for that foundation under that mill is $19,000. We have the cost per pipe, for steel, any insulation that might be associated with it, soundproofing, that sort of thing, the instrumentation associated with that machine, the electrical work, wiring and all the breakers, that sort of thing that are needed for it. So those are all broken out here and defined here. And this is part of that information that when you're moving forward into early stage feasibility, you have all this to start with anyway. Of course, you'll be refining that as you go along. But you've got all the machines, you've got all the costs associated with the work to get those machines installed and the prices of the machines themselves. Let's go back to our operating cost breakdown. So we have the equipment operating costs in dollars per ton processed here. The supply operating costs in the same terms. Our labor operating costs. In this case, we don't need a lead system operator. These three are not important in this fairly small project. And our administrative staff, again, in dollars per ton processed. The site development work we defined earlier is costs associated with that are listed here. The initial tailings impoundment, power transmission on site, camp construction, and the buildings for the mill itself. And then we simply come down to a summary. Here we try to break things down into timeline. This particular program can be broken down into 6 different phases. So in this case, we have pre-production, construction, and development work in the first 3 years. Working capital and operating costs begin in the 4th. But if we increase the production rate or change the nature of the constituents or the grades over time, you can break that down into 6 different segments over the life of the project. And that's pretty much it. You can, of course, save files for the projects and make adjustments any time you want. There's a print utility. You can print specific reports, all the data, production data, capital cost output, operating cost output, or the summary. And you can either have that print to a printer where you can do some modification to the nature of the output, or you can print it to a file, which is a comma delimited file that you can import into Excel. Anyway, that's our program. It's Sherpa for mineral processing plants. And as I say, it's a tool to help you estimate these costs and hopefully significantly reduce your workload, because it is not an easy task to design a processing plant in the early feasibility stages or scoping level stages for your project.